So if alpha, beta are the roots of the equation x square minus 2x plus 4 equals to 0, then for any n belongs to capital N, that means natural numbers, show that alpha power n plus beta power n equals to 2 power n plus 1 into cos n pi by 3. Okay, so this question is related to quadratic equations as well as the complex numbers, especially the De-Moivre's theorem. Okay, right. How to solve these type of questions? Oh, in competitive examinations, so nowadays the most of the questions are mixing with the complex numbers and quadratic equations. So here we have the complex. What is the quadratic equation? As x square minus 2x plus 4 equals to 0. For this one, he has given it has the two roots. One is as alpha and another one is as beta. Now try to find out the roots of this quadratic equation. So we cannot factorize directly. So to find the roots of this quadratic equation, we have to use the formula. What it is? So we can find the roots of the quadratic equation ax square plus bx plus c equals to 0 is by using x is equals to minus b plus or minus square root of b square minus 4ac by 2a. So now here I am direct writing it as x is equals to minus b. Here b is equals to minus 2 means it is simply plus 2 plus or minus square root of b square, that means b square is 2 square, that is 4, minus 4, a is 1 and c is 4 by 2a. A is 1, simply we can write it as 2 itself. Then we have here what it is, 2 plus or minus square root 4 minus 16. Okay, 4 minus 16 means minus 12. Okay, so minus 12 square root minus 12 by 2, and which can be written as, so square root minus 12 can be written as root 12 into root minus 1, and root minus 1 can be written as I, and root 12 can be written as 4 into 3. Okay, 4 is nothing but square root 4 is, we can write it as 2, simply it is 2 root 3 into I. Okay, the resultant is 2 root 3 into I. Then we can write as 2 plus or minus 2 root 3 times I by 2. Okay, so finally we can, if we take 2 as a common, we obtain the result of the values of x, the roots of the quadratic equation, 1 plus or minus what it is, I times of root 3. Okay, so here we are having x is equals to 1 plus I root 3 and x is equals to 1 minus I root 3. Let assume one root as alpha, then we are assuming one root as 1 plus I root 3, that is alpha, and another root is beta, which is equals to 1 minus I root 3. Okay, now what is the question is asking? He is asking us alpha power n and plus beta power n. Okay, so that means here it is nothing but alpha power n, that means 1 plus I root 3 whole power n, and beta power n 1 minus I root 3 whole power n, and plus, okay, so which is alpha power n plus beta power n. This we need to find out over here. So simply it is nothing but powers of a complex number. So that means we have to apply the De-Moivre's theorem. So before applying the De-Moivre's theorem, the complex number has to be expressed in polar form. So what is the polar form? R times of cos theta plus I sin theta. Okay, R times of cos theta plus I sin theta, where R is equals to where R is equals to square root of a square plus b square, or square root of real part square plus imaginary part square. So directly I am going over here. For this one, R is nothing but square root of real part 1 square plus root 3 whole square. It is nothing but 3 only. So we obtain this is as 2. R is equals to 2, and theta equals to, it is in the first quadrant, directly we can write it as theta equals to tan inverse of b, what is root 3 by a 1, which is equals to 60 degrees, that means pi by 3. Okay, theta equals to pi by 3. Now how the alpha can be written as, alpha can be written as R times of 2 times of cos theta. Theta is pi by 3 plus I sin pi by 3. Okay, plus I sin pi by 3. Now Okay, so alpha I sine pi by 3. Now we need to find out what is the question is asking. Alpha power n, that means alpha power n equals to 2 times of cos pi by 3 plus I sine pi by 3 whole power n. Okay, so which can be written as, so 2 power n into, so we can write this as cos pi by 3 plus I times of sine pi by 3 whole power n. So now here we can apply the De-moivre theorem. So now here we can apply the De-moivre theorem. We can write this is as 2 power n into cos n pi by 3 plus I times of sine n pi by 3. So what is De-moivre theorem? So cos theta plus I sine theta whole power n equals to cos n theta plus I sine n theta, which is alpha power n. Okay, right. Now find out the beta power n. So for the beta power n, so what we have to do to find out the beta power n? Okay, right. To find out the beta power n, we have to, it is in the fourth quadrant. In organ plane, it is in the fourth quadrant. Then in fourth quadrant, theta equals to minus alpha. So where alpha equals to tan inverse b by a. So here, what is alpha argument is equals to tan inverse of root 3. Okay, alpha equals to pi by 3, but the argument of this complex number is minus alpha, minus pi by 3. Okay, is it clear? So we obtain the argument of this one is minus pi by 3, and what is the modulus? It is again square root of 1 square plus minus root 3 whole square means 3. We obtain this as 2, and we can write beta is in the polar form as 2 into cos of minus pi by 3 plus I sine of minus pi by 3. Okay, I sine of minus pi by 3. Now apply what it is beta power n. We need to find out the beta power n. So directly by applying power n, I can write here it is as 2 power n into cos of minus pi by 3 plus I sine of minus pi by 3 whole power n. Okay, I sine of minus pi by 3 whole power n. Okay, so here we can write, apply the De-moivre theorem over here. We can write this is as 2 power n into cos of minus n pi by 3 plus I sine of minus n pi by 3 by applying the De-moivre theorem. What is De-moivre theorem? So cos theta plus I sine theta whole power n equals to cos n theta plus I sine n theta. Now the beta power n can be written as 2 power n into, so what it is, cos n pi by 3. Cos of minus theta equals to cos theta, but whereas sine of minus theta equals to minus sine theta, minus I sine n pi by 3. Okay, now we obtained alpha power n and beta power n. Now simply add these two. So our requirement is finding the alpha power n plus beta power n. So now we can add these two. So 2 power n into cos n pi by 3 plus I sine n pi by 3 is alpha power n plus what is beta power n? Again 2 power n into cos n pi by 3 minus I sine n pi by 3. So we can take 2 power n as a common. So if we take 2 power n as a common directly, so what it is, cos n pi by 3 plus I sine n pi by 3 plus cos n pi by 3 minus I sine n pi by 3 plus sine n pi by 3, and minus I sine n pi by 3 will cancel out. Directly I am writing over here as 2 into cos n pi by 3. Cos n pi by 3 plus cos n pi by 3. We obtain 2 cos n pi by 3. Directly now we can write this is as 2 power n plus 1 into cos of n pi by 3. So in the question he is asking us to show that alpha power n plus beta power n equals to 2 power n plus 1 into cos n pi by 3. So this is our required result. Okay, so he has given the quadratic equation. From the quadratic equation we are obtaining the complex roots. So the complex roots, for the complex roots the powers has to be calculated. Then if we find the apply the De-moivre theorem, we will get the required result. The next question is, if n is an integer and z is equals to cis theta, that means what he has given, z is equals to cos theta plus I sin theta. He has given that cis theta can be written as cos theta plus I sin theta, where he has given the condition for theta not equals to what is 2n plus 1 pi by 2. Then show that z power 2n minus 1 by z power 2n plus 1 equals to I times of sin n theta. So what he has given, we have to show the LHS equals to RHS. The LHS is z power 2n minus 1 by z power 2n plus 1. So which is, he has given the LHS. Okay, now which can be written as, now replace z is equals to cos theta plus I times of sin theta whole power 2n minus 1 by, we can write this as cos theta plus I sin theta whole power 2n plus 1, and here it is powers of a complex number power. Then we can apply the De-moivre theorem. So we can write this as cos 2n theta, okay, cos 2n theta plus I sin 2n theta, okay, sin 2n theta, next minus 1 here, and the denominator can be written as cos 2n times of theta plus I sin 2n times of theta by applying the De-moivre theorem, and here we have plus 1, and try to write out the real and imaginary parts over here. So that means we can write it as cos 2 times of n theta minus 1 plus I sin 2 times of n theta by cos 2 times of n theta plus 1 plus I sin 2 times of n theta. Okay, so now if we take minus as a common over here, the numerator can be written as minus of 1 minus cos 2 times of n theta plus I times of sin 2 times of n theta by, so the denominator can be written as 1 plus cos 2 times of n theta plus I sin 2 n theta. Okay, right. So here I am going over here to solve this one. So what is 1 minus, okay, here we can write this is as what it is, 1 minus cos 2 theta can be written as 1 minus cos 2 theta 2 sin square theta, then the numerator minus into 2 sin square theta. What is theta here? N theta. Simply it is theta is nothing but n theta, 2 sin square n theta plus, so what it is here in the numerator, sin 2 theta, it is in the form of sin 2 theta where theta is nothing but n theta, sin 2 theta, 2 sin theta cos theta. Then we can write as I am taking I into 2 sin n theta into cos n theta by, and in the denominator what is 1 plus cos 2 theta, 2 cos square theta where theta equals to n theta, okay, plus I into, we can write sin 2 n theta as 2 sin n theta into cos n theta. Okay, so now we can take what it is 2 sin n theta as a common, okay, 2 sin n theta as a common. So if we take 2 sin n theta or 2i, better, okay, right, I am taking it as 2i times of sin n theta I am taking as a common. Okay, now 2i sin n theta I am taking as a common in the numerator, then I can write this as cos n theta. Okay, but here we are missing the I. Okay, so to make it as I, then we can write this as plus I sin n theta. Just simply multiply, you will get the required result. Okay, are you getting? So what it is? 2I sin n theta cos theta. So this is the term. Okay, and 2I into I. What is I square? Means minus 2I. What is I into I? I square minus 2 sin square n theta. So we are obtaining, and if we take 2I sin n theta as a common, then we can get it as a cos n theta plus I sin n theta, and in the denominator take cos n theta as a common. Then if we take 2 cos n theta as a common, then we can write this as cos n theta plus I sin n theta. I sin n theta. Now we can cancel out 2 and cos n theta plus I sin n theta, cos n theta plus I sin n theta. Then we are obtaining I into sin n theta by cos n theta, which is equals to I times of tan n theta. So which is nothing but what is asking us to show that the required RHS of the given question. So this is the way of solving the what is given question using the De-moivre's theorem. So here the question is, if 1 plus x whole power n equals to a series he has given a0 plus a1 into x plus a2 into x square and so on a n into x power n, then show that so a0 minus a2 plus a4 minus a6 and so on. That means here the coefficient a0, a1, a2, a n are the coefficients in the series. Okay, are the coefficients in the series, coefficients of x powers. Okay, so but the first thing he has given a0, a2, that means even coefficient and having the alternative signs. Similarly, the second problem is also a1, a3, a5, a7, the odd coefficients having the alternative signs. So what this makes as an alternative sign? So here the series he has given, it is as 1 plus x whole power n equals to a0 plus a1 x plus a2 x square plus a3 x cube plus a4 x power 4 plus a5 x power 5 plus a6 x power 6 and so on. Finally we are obtaining this as which is equals to plus a n x power n. Okay, so to get the alternative signs, so okay, here a0, when how we get it as a minus a2? Yes, how we get it as a minus a2? So the square of a number must be a negative x. So if x square is negative, then we will get here it is as a minus a2. So then what is the possibility the square of a number is negative? Yes, it is nothing but iota. If iota, that means iota square equals to minus 1. That means if we replace x is equals to iota, then here we obtained is a2 into I square. I square is minus 1. That means minus a2 we are obtaining. Okay, so that means here the replace or substitute x is equals to iota. Okay, substitute x is equals to iota. So if we substitute x is equals to iota, what we obtain over here? 1 plus I whole power n equals to a0 plus a1 into I plus a2 into I square plus a3 into I cube plus a4, okay, a4 into I power 4 plus a5 into I power 5 plus a6 into I power 6 and so on, and it goes on the continuous up to an into I power n. So now if we simplify this, what we obtain a0 plus a1 into I, okay, plus, so what it is, I squared means minus 1, then we can write it as minus 2, and I cube is nothing but minus, okay, I cube, I square into I, that means I square is minus 1 into I, that means minus I, that means here we obtain it is as a3 into I plus I power 4 is plus 1, we obtain a4 plus, and I power 4 into I, that means I power 4 is 1, we obtain here it is a5 into I. Okay, and here we obtain this as I power 4 into I square. I power 4 is plus 1 and I square is means minus a6. Okay, so then minus we obtain over here a7 into I and so on. Now if we make the real and imaginary parts, what we can write this is as a0 minus a2 plus a4 minus a6. Okay, the even coefficients in alternative signs we are obtaining. Okay, so these are all the real parts, and if we make the imaginary, that means if I take iota as a common, what I will get a1, next minus a3, okay, plus a5 minus a7 and so on. So now here we obtained the required condition as 1 plus I whole power n equals to a0 a2 a0 minus a2 plus a4 minus a6. So and plus iota times of a1 minus a3 plus a5 minus a7. So here he is asking us to find these individual values, the real and imaginary values. In the question he is asking these values. So okay, right. So to find out these values, first we have to represent the LHS in the polar form. So what it is, I am solving the LHS. So what is the LHS I am solving here? 1 plus I whole power n. In previous problems we have seen how to solve this problem. So in the polar form we can write it as r equals to square root of 1 square plus 1 square, which is nothing but root 2 into cos, what it is, tan inverse imaginary by real 1 pi by 4, tan inverse 1 pi by 4 plus I times of sine pi by 4 power n. So here we can write this is as 2 power 1 by 2. Okay, so it is total power n. Okay, total power n. Root 2 power n can be written as 2 power n by 2 into cos pi by 4 plus I times of sine pi by 4 power n. Now we can apply the De-moivre's theorem over here. So how we can write it as 2 power n by 2 into cos n pi by 4 plus I times of sine n pi by 4. Okay, what is De-moivre's theorem? Cos theta plus I sin theta whole power n equals to cos n theta plus I sin n theta. So now if we write the real and imaginary parts over here, we can write this is as, so what we can write this as real part as 2 power n by 2 into cos n pi by 4 plus iota times of 2 power n by 2 into sine n pi by 4. Okay, right. So now which is the resultant of this one? So the resultant of this one equals to what we are having the RHS over here. This is RHS. Now compare the real and imaginary parts over here. So if we compare the real parts, what is 1 plus I whole power n equals to, we are obtaining a0 minus a2 plus a4 minus a6 as the real part. And what is the real part over here? 2 power n by 2 cos n pi by 4. Now these two are equal. This is equals to RHS. So what is the RHS here? This is the thing we obtained the RHS. Okay. So now, and the imaginary part equals to a1 minus a3 plus a5 minus a7 equals to 2 power n by 2, 2 power n by 2 into sine n pi by 4. So now we can write the summary of this one as, so what it is, a0 minus a2 plus a4 minus a6 and so on as, so the real part, this is 2 power n by 2 cos n pi by 4, and the imaginary part a1 minus a3 plus a5 minus a7 and so on as the imaginary part, what it is, 2 power n by 2 sine n pi by 4. This is the question he is asking us to show that the required result. Simply substitute x is equals to 1 to we get the required result. So whenever an expansion is given, and in the expansion we are getting the quotient sign size, and alternatively try to put it as x is equals to iota, then we will get the required solution. Thank you. I think you understand how to solve the problems using the De-Moivre's theorem.